Introduction to OpenGL. OpenGL is a cross-platform graphics API that is widely used in computer graphics and game development. It provides a powerful set of tools and functions for creating stunning 3D visuals and interactive experiences. OpenGL allows the developers to interact directly with the graphic hardware, enabling the high performance rendering and advanced visual effects. Uh, Initializing an OpenGL context. Before you can start rendering and anything with OpenGL, you need to initialize the OpenGL context that involves setting up of windows, creating a OpenGL rendering context, and configuring various OpenGL settings. Uh, first, first step is creating a window. You will need to create a window that will display the OpenGL's graphics. This step is typically involves the using of a platform-specific libraries like GLFW or SDL. Creating an OpenGL context. Once you have a window, you create an OpenGL context associated with that window. The construct defines the version of the OpenGL you will be using and any special features you might need. Setting up a OpenGL. After creating the context, you can set up the various OpenGL settings such as the clear color, view password size, and specific rendering options. Rendering a simple shape. Rendering is a basic shape is a fundamental in understanding the OpenGL. This process involves defining the shape and geometry, configuring shaders and drawing the shape of the specified viewport. And you will use the OpenGL core commands to define the vertices. Defining a shape geometry, you start by defining a vertices that makes a shape. These vertices are stored typically in an array or a vertex buffer object. Creating shaders. Shaders are a small programs that can run on a graphics hardware and control how the vertices are transformed lit, and how pixels are shaded. Drawing the shape, you can then draw a shape using the OpenGL commands like the GL draws array or the GL draw element, passing the vertex buffer or a shader information. Applying color and texture. To add visual interest, you need to render objects. You can apply colors and textures. You can either define a single color or an entire shape or textures to create more complex and visual patterns. The textures are the images that are applied to surface and can add realism, details, or artistic elements to your models. Colors can be defined by RGB, red, green, or blue, or RGBA, red, green, blue, alpha values. These they are usually specified in shaders and can be applied to vertices or fragments. Textures are images that you need to load in OpenGL and apply to surfaces. They are used to create realistic textures like wood, stone, or metal to or abstract patterns and effects. Transforming object into 3D space. Transforming is essential for manipulating objects in 3D space. OpenGL provides a matrix-based transformations like translation, rotation, and scaling, which can be combined to create complex movements and positioning the objects. Translation moves an objects along the XYZ axis. This is useful for positioning the object within the scene. Rotation rotates an object around the specific axis. You can rotate the objects around the XYZ or Z axis or any combination of them. Scaling changes the size of an object. You can scale objects up and down along the XYZ, XY or Z axis. This is useful for creating objects of different sizes and adjusting their proportions. Lighting and shading. Lighting and shading create a realism in the depth of 3D graphics. In OpenGL, you can define a light source in material. For shading models, calculate interaction between the light and the surfaces of the creating a realistic visual effect. Light sources can be directional or spot. Materials Materials describe how the surfaces interact with the light. They have properties like ambient, diffuse, or specular colors. They affect the how light is reflected or scattered. Shading models are the algorithms that calculate intensity of the light at the point on the surface. Popular models include the flat shading, Pong shading, and the working with the cameras and the viewpoints. Cameras and the viewports are essential for defining the perspective of the region of the scene that is rendered. A camera defines the position and orientation of the 3D world, while the viewpoint specifies the area on the screen where rendering output is displayed. Handling user input. User input is essential for interactivity in 3D applications. You can handle user input events like keyboard presses, mouse clicks, and joystick movements. This input can be used to control the objects. Optimizing the OpenGL performance. Performance is crucial in the OpenGL applications, especially in the real-time applications like games. Optimizing the performances involves the techniques for reducing the rendering time, minimizing memory usage, and improving efficiency. Vertex buffer objects. Vertex buffer objects vertexes on the graphic cards, minimizing the data transfer between the CPU and the resulting in the faster rendering. Index buffer objects stores the indices that define the order of which in which the vertices are drawn. Shader optimization optimizes the shaders can significantly improve the performance. Texture optimization choosing the appropriate texture formats and compression techniques can reduce the memory usage and improve the rendering speed. Conclusion: OpenGL is a powerful and a versatile graphic API that offers a wide range of capabilities for creating stunning visuals, interacting experiences. By understanding the fundamentals of the OpenGL and the various components, you can unlock the full potential of the 3D programming. This there are numerous resources available on the online for further enhance your knowledge, including tutorials, documentation, and online communities. Thank you.